So this is my final YAML file for application deployment and service deployment. Okay. You can see my screen, right?
Yes.
So here you can see this is a deployment and the metadata name of the deployment is blue-green deployment. Then replica set 3 containers, I mean 3 pods created when running this one. And image name is same image name. And container pod 8080. Then coming to service, you can see
Was this missing in the yesterday's YAML file? From line number
YAML file, one thing is missing actually, that it's the target port. Okay, here coming to the service, we use the target port as 8080.
Yeah.
But we need to put HTTP here. Okay, that's the reason I think that application is not taking when using URL. Here you can see the container port is 8080. So we need to mention the protocol here actually. HTTPS. And the source I'm saying, like, this is our node port, okay? I mean, where we accessing the application using the URL. So we accessing using the port number 80. Got it, all of you.
So what was there in place of HTTP yesterday?
Yesterday, I put 88 instead of the target port in service. This is a service actually. So here, I think I will show you. Yeah, see, this is not that one. Okay, I missed that YAML. So yesterday we put here 8080 like this. Got it.
So we don't have to put like use a port number. It should be a protocol.
Here, yesterday we put like a target port as 8080, okay? But in this case, you can see under the port.
Oh, so here the name was written HTTP.
Yes, this is a label actually. So this label we need to provide here. So it will take above, above container port. I mean routing. Actual our target port is the container port, okay, 8080. And this port is locating to the node port, okay, the virtual machine port. Actually, using load balancer, we didn't bother about this because the load balancer opening this port.
So the container port is the target port.
Yes, right. This one. Above we already mentioned that.
Right. So, but you're saying it should be like HTTP, like the protocol instead of 8080. We are not supposed to give the port number here.
We just mentioned the name. I mean the label that we provided for the protocol. I mean the port and the protocol. Above you can see coming to the container. I mean application part. So
Okay,
here
here
we already.
also in the comment you have written like matches the container port name
Yes.
in the deployment.
Yes.
So here on the top, that means whatever the name is written, we have to write here,
Right.
right? Okay, so it could be whatever is needed, like HTTP, HTTPS, or whatever
Yeah,
is written.
here you can see the comment matches the container port
Yeah,
name
yeah, yeah.
in the
Okay.
deployment. This is
Yeah.
our deployment. That's the label in the
So
deployment.
deployment and service names have to match.
The label matching.
Yeah.
I mean pointing. Yes. Similarly, here you can see the selector. That means that label that we use in that deployment. See where we mentioned blue deployment. So this will pointing, the service account pointing to the deployment, Boogie deployment.
Okay. Yeah. So the bottom has all the details of the service, and the top has all the details of the
Application deployment.
applications
Deployment.
version 1 deployment.
Yes.
Okay. So
Blue
in
is
this
our
application
not
where so in this application where the service is like connected, like which port and all those stuff, like all those details will come at the bottom, right?
right.
Yeah.
How the application is exposed, which
It is,
port is
yeah,
used, like that, everything
right.
is.
Right. Okay, sir.
For example, if we didn't expose this application to public, what would we do? Anyone can? No. Now we are going to expose this application to public. But the requirement is we didn't expose.
What is the question actually?
For example, this configuration, I mean, this settled configuration is we exposing the application, okay, to the outer world of Kubernetes.
Okay.
The requirement is we didn't expose this one. So what will we do?
I mean, the end user is not able to access the application.
We didn't expose this one to public.
Right. If you don't endorse to public, the end user will not able to access the application.
Yes.
So the 8080 is the public, the port number for like for public. No. I think I'm getting confused. How do we define public, sir?
The deployment defines what is the container port, and the service just matches
Yeah.
the label.
No, that is okay. But the question which he asked, sir, so how are we gonna make it public, or is it a private now? I mean, how can we check this thing? How
That's
do we
all
know?
came under the type, service type. I think I already explained there are different types in services. Cluster IP, not port, and load balancer. If we provide load balancer, that means we are exposing our application to the public or
Public.
outer the Kubernetes. Okay. If we select cluster IP, that means the application is only accessible internally within Kubernetes cluster.
Within the same cluster.
Right. No one can access that application outside the cluster. So here we need to change accordingly so we can make this application.
In what circumstance, in which scenario are we going to use the cluster IP? Is it for the QA environment like that? We want to deploy only for the QA environment. We're going to use the cluster IP.
No, for example, we have an application, okay, microservice application, different modules there. For example, front and back end database like that. So coming to database, we didn't expose that database service connected to load balance or anything because it's database, right? So we need to mention cluster IP there. You got it?
Got it.
Yeah. So similar service like the service that we didn't expose, then we can use cluster IP.
Yeah, only from the front-end application, we're going to use the load balance.
Right.
Yeah.
I
I
think
think
we
I didn't
deployed
understand.
an entire application, right? Not in this section, right? I mean in batch.
I'm sorry, Tawfiq.
An entire application deployment. Tire. One
Okay.
tire.
10 tier,
Okay.
no, we didn't do that.
Okay.
Yeah.
I think I
Like-
didn't understand Mahesh's question. I'm sorry.
I was telling that the type which we used here are load balancer. When we're using the load balancer, the application can be accessed by the end user, I mean the public. So, for example, you take that the Facebook is application. End user will be many users like me, you, Pooja, Amol, everybody will use the Facebook application. For the database for that Facebook, nobody can access that one. For the database, the type which we are going to use is cluster IP. Okay, database will be the backend application. So the application, the exact Facebook application that everybody can use, that is the front end. We use the load balancer. Got it?
And which one is the third one, sir? The type?
Cluster
You
IP
said,
for load balancer.
and there was one more. You were saying like there are a few types, different types. So what are the other
No.
types?
These are the common one. Three things. The three
So
types.
which one is the third one, sir?
First one is cluster IP, default one. Then node port.
Node
Then
port.
load
Okay.
balancer.
So node port is
Node port is actually node port is we exposing the application actually. That is we use for testing purposes, not configuring load
that is
balancer.
again private, right?
No, it's public.
It is public?
Yeah.
Okay. So are you gonna explain the three-tier architecture deployment? Three-tier architecture of
Yeah.
application? Yeah.
Yes.
In this course.
Yeah, it's
Huh.
I will explain.
Okay.
Today I will explain. Okay. No. Also, I will show you how to deploy.
With the lab, sir. Otherwise, theory doesn't work. Like theory is okay.
Yes.
Yeah, with the steps we need to know.
Coming to the step, it's a predefined YAML file there. So we just apply those files. So it will create 10 application. 10 different services that are interrelated with a single application.
So that was you were saying 10 tier.
Yeah. 1, 2, 3
Okay.
like that. So it's 10 services.
Yeah. 10 services. Okay.
Okay, cluster is ready. Yeah, fine. So yesterday, yeah, for our deployment, I already created those files. Okay. See, b.yaml means blue deployment, and so s.yaml is for the service. Okay, I will show you the configuration. See, this is the deployment file s.yaml. This is a service type. Okay. So the blue deployment, I mean the blue application is our stable application, okay? And the service for that we using for the blue is our stable service also, okay? So yeah, now we are going, I'm going to deploy, okay? But in real world scenario, this application already running, okay? So we just uh, deploy the green, the version 2 only, because the stable application can't run there. Okay, both are created. Deployment created, also service created. Three port running. Also, I'm checking the service. Get SVC. So the load balancer is creating. So this will take some time because right now we define the load balancer and apply. So at that time it will create the load balancer. This is creating by AWS. Okay. So AWS will creating a classic load balancer for this application. Copy, paste.
So what we did, like initially, you were having a files. One was a b.yaml and other one was s.yaml, and then
B is our blue deployment file. Okay.
right
The S means service for the same blue.
service. Then what you did, you created and you did few commands you wrote. What was for that?
That commands actually for applying, I mean, Kubernetes commands. See, first command I used this one,
Mm.
applying. Uh, Using a single apply command, I mentioned the both file. That's all. Dash
So what
dash.
what it does? So what it does, this command?
This is applying command, kubectl applying, which
Okay.
means
Okay.
like we are going to execute that files to Kubernetes from this local
Okay.
machine to Kubernetes. We are
B.
interacting Kubernetes
Okay.
with the kubectl command actually.
Okay.
This is the interacting command.
Uh-huh.
So in real world, what will happen in backend? Okay. So this is my
Mm-hmm.
local machine. This is my
Mm.
local machine where I am using the kubectl and everything. Okay. I
Right.
mean, local machine in the sense of this is the local machine. This EC2 machine.
Mm.
So also, yeah, this is the local machine. And we have a Kubernetes cluster running here with the master part and worker, two node there, okay. This is a master part and this is two node. And using kubectl, okay, we already connected with our Kubernetes cluster. So
So this first
apply.
one is the EC2 machine, right? The first
Yeah,
one.
this is the easy.
Yeah, this one. This is EC2. Okay.
Yes. Also, we can use our local machine as well, okay. So
Yeah,
in
yeah.
my case, I am using the EC2
EC2. Okay.
and already installed the kubectl here and
Mm-hmm.
connected with the Kubernetes. Okay,
Mm-hmm.
so we have the files here, the YAML files here. Using apply kubectl apply command, what will happen? The YAML pushing from this machine to the master part. We are interacting with the Kubernetes API server. Okay, so
Mm-hmm.
we pushing that code, YAML code to API server to deploying the application. So the API server sending the request. I mean, taking the YAML files to the scheduler and controller there. So the scheduler will finally the scheduler service scheduling the pod deployment to the node. So it will creating the pod and the container. This for example, if you are deployed three container, right? So the first two might be goes to the first node. This is a node one and this is node two. The third will goes to the third machine. Okay, like that. I mean third pod with the container. So if one pod is down, our application is successfully running here. That's why they use,
Replica.
yeah.
Okay, replica because of replication.
Yes.
Okay. So what are the other two, three commands after apply command we have used for like connecting to the master and then pods and all that stuff, scheduler.
Then I used get pod to listing the pods.
Okay.
We
How
know
many pods
the,
it has?
the
Yeah.
application is running fine or not. So here if it's fine because it's created
It
three
has
pods
three pods.
and the
Okay.
status are also running.
Running. Okay. Then we checked it. Basically, after apply, we checked the status of the pods.
Right. Then same
Okay.
commands. These are the Kubernetes command actually.
Right. Yeah,
So
yeah, yeah.
after that I use kubectl get service. I need to know the service is created or if created, I can see the external URL as well. So just using it will show or it will list same
That
thing.
is okay.
This is a default service. Okay.
This is
This
default. So
service we
every time
created. Yes. This is
this
default
blue service
Kubernetes.
load balancer is default, so it will come
No,
every
no, no, no,
time.
no, no, no. This is we
No.
created.
Blue service we created. Okay.
Right. The Kubernetes is default one.
Okay. Mm. Hmm.
The
Okay.
application is running fine. Reload. See, this is our
Yeah.
blue deployment application. Okay, so this means only the blue application is, I mean, we getting the blue request only, like all the requests hitting the blue version. This is just a visual representation. Okay, the application is currently blue. Got it.
So this blue means like this is the blue is signifying the traffic, like these many requests are coming.
Right. Just a representation.
Yeah, visual request.
Yeah.
So what is this for, sir? Start and stop? To start and then stop it,
That's
accepting that request or something like that.
yeah, it's a representing. I mean, it's a stimulator. Like we are not going to stimulate actually, just taking the traffic. So in
No,
this,
what is the start and stop button here?
yeah, that's a application specific application stimulation actually. So just stopping, starting.
Acha, it is not the real time. It is just for practice purpose.
Right, right, right.
Okay, okay, okay. So in real time, it looks like the same way or like different?
Real world, this is just a blue-green deployment representation only. Okay, this specific application, real world scenario, we will deploy application, right? Real world application, like any e-commerce application or any other application, website application, lot of services there.
Okay.
You
It
got
would be
it?
like the real application, how it looks like.
Yes.
Okay. It is just like a lab
For
thing, so
example,
that's why they just make a simulation.
yes, yes.
Okay.
Uh, yeah, why I'm using this image, you can see whenever we switching application to green, so the green dots appear here. Okay, so that I will show you. So what we need to do, we need to write up the green deployment. Okay, so green. This is our new application.
Mm.
So everything we need to change to green.
So, sir, what was blue is a different application and the green is different application.
No, they're the same application. It's just showing you how you can switch and balance things.
Not
There's
No,
same
no.
enable
application.
and
The
blue green,
version
right?
changing. Version is changing actually.
So version is like the green is the better version than the blue one.
Blue is the stable version actually. Stable
Okay.
means the running application. For example,
So
real
the
world.
existing
Okay.
application and the green is with the changes, like whatever the changes.
Yeah, we have a
Can
we
we say?
deployed a application. Okay, we
Hmm.
deployed a application. The application is running fine.
Hmm. Hmm. Hmm.
This is a e-commerce application. Okay, and it's running R4 running fine. And this is our version one.
Right.
Because whenever we deploying application, initially we called as version one, right?
Yeah,
So
the
whenever
first version.
after some time we need to add some new features to the application, then we called as version
That
two
becomes
like that.
version 2. Yeah.
Yeah. So the version one is running fine and running fine in Kubernetes, okay, with 3 or 5 or 6 pods, okay, fine. So
Okay.
then we need
Okay.
to deploy the version two because version two is ready for deployment. So we
And
need,
version, so what is the
yeah,
difference between version 1 and 2? Like there
same,
must be some different features or
same,
say
same instance with the updated features
updated features. Okay. Yeah, that's what
or
I was saying.
new features, right?
No
So
new features.
yeah, new feature.
New features. With the new features. Okay.
Yes, the same application with a new feature. For example,
With the
say
new features.
yeah,
Right.
this is the version one is considered it's a application WhatsApp. Okay, so the WhatsApp
Hmm.
that WhatsApp does not have the status features. Okay, because
Hmm.
we can set the status stories like that. So they build okay before. I mean, V1 does not have that status feature. Then again, the developers modify or adding that features like users can adding their status stories like that. So that is came in the version 2. So we need to deploy the version 2 to the end users. Got it?
Yes, sir. But sir, in Canary, it's like the percentage for
Yes,
the
yes.
traffic. But
Yeah,
so
in
like
Canary we deploying the new version there. That new version we called as Canary. And we
no.
shifting the traffic little percentage to the Canary. Rest of
Oh,
them
so
goes to stable version. There is stable version and Canary version. Two applications there. Here we call if we go with the blue green, then we called the stable version. This is our stable actually.
hmm.
Stable application. Kind of stable. But we changing that stable after fully shifted to like that green is successfully running, then our stable goes we called as the green as our stable like that.
So sir, this one blue green doesn't has that parameter of a percentage, right?
No, no,
That
no, no.
is only available in Canary.
Right, right.
Okay. And in Canary also we have a two versions, definitely,
Yes.
right?
Coming to Canary, there is no downtime for, for the switching application because we shifting traffic gradually. So there is no issues with
Gradually.
yeah.
But
In
in
this,
blue green we have a downtime issue.
in this case, I think a little like seconds of something like that.
Yeah. And it will show a latency, like I saw that on the page which you showed, like the application page which you deployed. So it was showing latency. So probably in the real time also we can see the latency, like how much the delay is there or downtime is there, right?
Right. In real time, it's a seconds of matter actually. One or two. We can see, okay, when I am switching, how much time
Okay.
it will take.
Okay.
So this is my latest application, like blue green. Sorry, green, like the new version. Okay, green deployment, green. Also, I changed my image here. You can see this is
So this
going
is saying sorry, sir, sorry to interrupt you. So in the top it says replicas 3. That means we have 3 pods, right?
right.
Okay.
So total we got 6 pods, one for the blue and one for the green. Sorry, three
In
for
total. Okay.
blue and green. Yeah. So
Okay.
I'm going to save and exit. Now I'm going to run. So the green deployment is successfully executed. See, 6 pod. This is the new application, and this is for the old application. So in real world, what will we do? We will test the green application. Okay, like testing means we will do the same. We will expose the application and testing manually with mm, some users. Okay. For that, we need to create a separate service for the green. But in this case, I'm not creating anyone. I'm just routing. I assume that the green is running successfully, so we can route switching the traffic from blue to green. How we will switching the application manually? Just as of now, you can see this is our application. All the requests hitting our blue version. Okay, blue version of our application. So now we are going to switching. Switching it's simple. Just open our service, table service connection. Okay. Nano stable service is YAML. That is the service connection that we are pointing with the blue service. Okay. Currently. So how we will selecting that is blue, the selector. See here you can see the matching label in the deployment. So here we can change blue to green. So what will happen? So we have a application blue version, and now we created the green version as well. Okay, this is the blue and this is a green, and we have a service connection. This is our service connection. Okay, consider this is our load balancer. Okay, so because this is the load balancer. So all the requests hitting the load balancer and pointing to the blue version, right? So now we just open the load balancer configuration and changing and the selector port selector in currently the port selector is blue. So now we are going to change its green. that we configure in load balancer. This will remove. Okay. So the switching traffic goes to green version. So for that, we need to provide the green here. But because there is a green deployment currently running in our Kubernetes. Save and exit.
Can
Now
we
we need
automate this thing, sir, in real time?
not
No,
automating actually. We can
every
automate
time we have
using
to do it.
Argo CD. We can automate.
Hmm.
So we configure after the configuration. We need to apply.
Again, those two, three commands.
Only apply command.
Only apply. Okay.
S.yaml. Hit enter. So here we can see it's configured. So we can go see
Hmm.
how fastly it's switching. Now it's green.
Hmm. Yeah.
So if you're facing any issues in production, like green version is having any issues in production, we can easily roll back. Just came here and change
To
to
blue.
green. Sorry, blue.
Hmm.
See, now it's blue.
Sir, why it is showing green here?
Now it's some real well some API calls are there. That's all. That will remove actually.
Because the latency also showing something.
Right.
So that means the green has not removed completely. It's just
No, no,
still
no,
there.
no, no. Some cache. See, now it's all removed.
Yeah. But prior to that, it took little time to go completely off, right?
No, that is cache or API calls. That's why it's seeing the green there. When I refresh the page, it's showing all green. So this
Okay.
is the way we deploying using the blue green strategy. Okay.
So how the requirement come in real time,
In
like how,
real time, there is a new feature. Then the top architect or IT manager or who is managing the entire IT, they will selecting. I mean, that strategy, which strategy that we need to going or performing for the new deployment. So there is a
so
discussion with the DevOps team as well. So we can say like we can go with the blue green or canary like that.
and then they decide like whether we
Yeah, they will
want to
approve
switch
and
to blue or green.
yes,
Accordingly, we change.
right,
Okay.
right.
So in real time, how long it takes? It like now it took hardly less than a second, but
If
in real
if
time
if
because
if,
the
if there
applications
is
might be
yeah
bulky.
if there is a there is no issues, then it will take 1 or 2 hour maximum.
1 or 2 hour
Yeah,
for a big application, like heavy
maximum. Yeah,
application.
maximum.
Maximum 1 hour to 2 hour, or minimum is like few minutes, maybe.
30 minutes like that. That's all.
Okay.
Because everything is tested and running fine in the pre-pod stage or staging, right? So just do the same thing in the production. That's all. So coming So coming to the microservices, okay, like tier of different. For example, we have a application. So the application have a front end and a back end. So what is a front end? The front end means where the users can access the application user interface. Okay, so we call as that is a front end. Okay, so for example, the google.com, we type google.com, we can see the Google interface there. So that's a front end of the Google. So that front end is written with some application as well. Okay, like any C using the C program, they are building the front end application. So that is front end written with any of the language like Python or C. Python. Okay. So that's a front end application. So we coming to Kubernetes part, we will expose this front end application using the service load balancer. So the user can access our application, right? Also, we have considered that we have a website for this front end application because we need to collect the user data and store in our database. So we have a database. This is our backend. Okay, but coming to the database service, we didn't expose the database service to load balancer, right? Because this is publicly visible. So in this case, we using the type as cluster IP. So the type cluster IP. Here the type is load balancer. If we have more, for example, this is the scenario for a simple application. Okay, we have one more service there for that is for consider this is a e-commerce application. Okay, so some services there, services in the sense of microservices. Okay, so this is the payment gateway. Got it. So these all the application internally, these all are interrelated. Okay. For example, this also we use the cluster IP type as cluster IP, and in that configuration, YAML configuration, we will selecting. I mean, the labels are there, right? So how this is the one of the pod. Okay, consider like that. This is one pod. This is another pod. This is another pod. Three pods are there. The three pods for a single application. Okay, e-commerce application. So three different modules there. This is written the first container or the first port, first container application written by Python, and second the database, third payment gateway written by C hash like that. So this is the setup, microservice setup. Okay, coming to microservice. That's one of the benefit that we can use different language for different modules. Before microservices, the monolith there. Okay, monolith. This is an application like architecture. Okay, monolith. So this is microservice where the Docker and Kubernetes or these infrastructure we deploying microservice application. And yeah, for example, Netflix around 900 plus microservices there. 900 plus. That means that much containers running. So yeah, coming to the yes, internally each services is connected. Okay, because for example, if a user log in here, I mean user searching some content. This is a e-commerce website. Okay, so here we can see the products here. So whenever a user selecting a product to cart, so we need to create another one for cart. Cart is another service. Okay, so whenever selecting a product to add it to cart, this product came to the cart of the specific users actually. Okay, so here we can see, coming to the cart, we can see the item that we selected. Then here we can see the checkout. Then for checkout, another service there. So we take up from here to the checkout page like that. After that, we go to the payment portal. You got it. Also, there is database, everything saved in the database like that. So
So the question is like how it is different than like in terms of containers, like you said, like gave the example of this 900 plus containers. Services are using that many containers, but if we are using this micro services model, then how we are using the containers? Are we using the same container for all the different modules? Like front end, we're gonna use the same, and when the front end part is done, then the same container are being used by the backend database, and when its part is done, then it will use by cart, or like the sequence. Is it
uh,
like that?
you mean within a single container we deploy entire application, right?
Yes.
No, 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 no. It's not.
No.
No, no. It's
So how
a
it is
heavy.
different than monolithic?
Coming to monolith, we deploy entire application to infrastructure like VM like that. In that case, what will happen? All the application wrap up in a single.
So what I understood from the theory part, the main concept and the difference between these monolithic and microservices, monolithic, all the modules are dependent on each other. So if
Hmm.
anything breaks down, then the entire application doesn't work, right?
Right, right.
But in case of microservices, all the
If one
modules
is
are
down, for
self-dependent. If one is down, the rest of the modules
yes, yes,
still they kept working. So
right,
that
right,
is the very broad definition of these two
right, right.
concepts. But I
Also,
want to understand, sir, like how sorry to interrupt you, how the containers are working. Like because here you are trying to teach how the containers are working. So I'm still not getting like how the containers are working in these two different concepts. What is the difference like yeah, in working of containers?
so the monolith application, this is a traditional way of deployment. Okay, so
Right.
coming to monolith, the we can use a single application to build all that services within the application. Coming to monolith, there is different modules there, like different pages. For example, the front end, back end, like that. So we need to write up the entire application code with a single program. Like if we choose Python, then we need to go with the Python to build all the application. That's one of the demerit.
Right. Right.
And coming to any one of the application, or sorry, any one of that service is down or making an issue, then we need to stop the entire application to troubleshoot,
Right.
because it's written with a single application, that's single program. So coming to microservice, we can use different language for different service. Here we can see 1, 2, 3, 4, 5, 6, 5 services. So we can choose different languages for building. Any
Right.
issues with
Right.
any of the services, then we can just stop that service and troubleshoot the issues. Rest of the application is running fine.
Right.
So it's a coupled. This is coupled one, and microservice is
Other
decoupled one.
one is decoupled. Yeah.
Yeah, decoupling
But
the
how?
services.
Okay.
And we run each services. I mean each coupled services. For example, the front end we return with the Python, and we
Hmm.
set up the. I mean we define the dependencies, libraries, everything, and we deploy inside a Kubernetes container. So it will running fine there, the front end. And
Hmm.
this front end is needs to connect with the backend service. So what we need to do, we need to specify in the YAML manifest of the front end. This is connecting to the service backend and service payment, or like that we can define. inside the
Like the
config.
way we did in your
Yeah,
example,
yes,
s.yaml.
yes.
So in that, like in this case, if I take the current example, then it would be like instead of s.yaml, it would be like backend database.yaml, something like that, and payment gateway dot. Okay, okay.
Right.
So the number of services it would be equals to the number of the services we'll write in that YAML, right? Am I right?
Right. We
Yeah,
need to
has to
create
teach the next
separate
class.
service for each services, each
Each
container.
service. And that is called the 10 tier, what you were saying, right?
Right. I will show you a 10-tier deployment.
I think Pooja is ready to teach a class, I think.
I would love to, but I know I'm not.
It builds that way, like as you keep going, suddenly it builds. Teaching is like a way to really develop your ability.
Oh no, actually, I think now I have started getting few terms, and at least I am getting the context. Initial classes, everything was new for me.
I think this whole architecture is designed around constantly being able to click and run things from everywhere. Everybody and their grandmother is like on the internet and keeps asking for stuff, keeps buying stuff. We want to have many windows open. So it's geared towards that, like scale. In the old days, you used to just have one computer running one program, and it was more like just you wanted to calculate something or know something. It wasn't just this constant either mindless scrolling or mindless purchasing online.
So here you can see this is a 10-tier microservice app deployment. Okay. So this is a online shop. See, we will get this much services like for ad service, card service, checkout service, currency, email, front end, load generator, payment service, catalog service, recommendation service, Redis cache. This is the database and shipping service. And here you can see the architecture. So the users accessing the front end. See, the users accessing the front end. Okay. Then go to the ad, recommended. Then these are the services. Okay. The ad is one service, recommendation is another service. Then checkout is service. All connected with front end. Okay. I mean, you can see the arrows. The front
Sir,
end
what
is
is
not.
this HTTP thing?
That's a request came from the user to the front end application. This is a user and they're using HTTP protocol. Okay.
Okay, that's what it says.
Yeah. In the service type, we mentioned HTTP. Same thing.
Yeah.
എന്തോടെ ശബ്ദം കേട്ടാ I'm audible, right? All of hello?
Yes.
Yeah,
Yes, you're
here
audible.
electricity just gone. That's
Okay.
my modem is turned off. That's why. Now I'm switching to my phone.
Okay.
So, yeah. So this is the
Okay.
architecture, the entire application architecture. So we have a lot of modules there. These are our modules. So all modules are interconnected. Here you can see the checkout is connected with the product catalog, card, shipping, and this is architecture actually. As per our requirement, we need to architect like what we need. Okay. Also, you can see the YAML file, Kubernetes manifest. So these are the different YAML file for each services.
And we will get it from the developers team.
Uh,
Am I right?
Mostly we need to create, otherwise we will get from them.
Okay.
See here, you can see this is the application file, okay, and this is a service. So here you can see the type is cluster IP. That means it's only these are service. Most of service is private one, like only for internal communication. Here you can see this is a front end YAML. So front end YAML service you can see its type is front end external and it is pointing to load balancer. So only this front end is exposing to public for Redis.
Front end, and one more thing was there at the corner. I think generator, some
For
load generator or something. Well, in the
where
architecture, there was one box at the top
that is
in
for
the architecture.
that is for load pushing load actually.
So that is also public one, right? That is also using public.
Right.
Mhm.
So this is a service for front end. Sorry, database. So this is the image, Redis alpha and port number, everything we can see here. For deploying the same application, we can simply clone the application from here, cloning, and go to the machine where we're working. And just refreshing. So using git clone. Git is not installed. So I'm installing Git. Okay. See, I'm downloading that repository. See, this is a repository, CD. So I'm just going to the repository. Here we can see the manifest all there. So how are you deploying that application? Here we can see. This is a running command. Same command, kubectl apply command. And also we just mentioned the port path where we keeping that Kubernetes files. This one, copy, paste. See, this is a Kubernetes file. If we have lot of Kubernetes YAML files, okay. So in this case, we are using kubectl apply file. Then file we mentioned that release Kubernetes manifest. This is a folder where we are keeping the manifest files. So hit
So this
enter.
is the path. After flag F is the path, right?
Yes.
Hmm.
See, it created. Its container creation, uh, 10 containers, because it's mixed up with our blue green also. See, this is a green, first of them for the application. Seems it some is container creating stage that will take little time. Yeah, now it's only 2 containers waiting, pending. Also, we can check the service. So it will create one more service for the front end. See, this is a front end external. So how we are accessing the application using the URL.
And sir, what about the backend
Back and see
services?
the Redis. This is a database.
No, so the thing like for accessing the front end, you said we got that URL, okay. But what about if we want to access the other services which are
No, no.
private?
That is not directly we accessing other services. Only the front end.
Okay,
You
so
got
we
it.
cannot access
No,
the
no, no, no. Through the front end we can access. Got it. So this is application is not running successfully because 2 pod is not running there. The Redis connection is not running because the Redis. See, this in this case the application is not running because can't access the cart storage. That is because our application cart is a Redis. Okay, this is not running fine. That's why the front end application seems the error. This issues I think might due to storage issues of our node. Okay, so that we need to delete the deployment as well. kubectl get deployment. Still, 2 services pending. Okay, this is a reason why. I mean, reason that we using a simple machine here. kubectl not kubectl kubectl tl not. So only 2 node here. In this 2 node, actually, we are running 3 applications. That's the reason. This is for this services. It will those services need the resources and everything, right? So that's the reason it's not taking. Otherwise, our application running fine.
So we cannot check the private one like by
Yeah, the
accessing.
Redis,
It's just
the
like the
Redis,
front end we can check.
yeah, Redis is
Whatever is
fine.
the public.
The Redis is fine now. We'll check. If I delete the blue deployment, that specific machine get more service, I think, more resources. Also, I'm trying to deploy the green as well.
Your voice is breaking.
Now it's fine, right?
Sir, we missed whatever you said.
Now I'm stable.
Yeah.
Yeah, now the application
Yes.
is running successfully. So this is an online sample application where we can buy and add cart, like how much count, then go to art. So these are different services actually. Okay, I mean we are now switching to different containers. Got it? See, now we are in the cart. This is in product. So each services we are switching to different services. We can go to cart and we can see what are things that we saved. Place order. So this is a way we deploying application. I mean microservice application deployment happening in Kubernetes. This is officially Google's deployment application. Okay. So anyone have a doubt?
No, sir.
No.
Okay. Then I will share some YAML file. Okay. So you can do it on your Kubernetes cluster weekend. Is that fine?
Sure.
Okay. Then we can wind up today's session, right?
Yeah, so sir, along with that, can you please share the commands as well?
Yes. We'll share. We'll share.
And like just like the task you shared last time.
Sure.
Okay, sir. Thank
Okay.
you.
Bye. Bye all. Happy weekend.
Bye.
Bye. Happy weekend.
too.
Good
Thank
morning,
you.
Perfect sir. Good evening,
Yeah.
everybody else. Bye. See you
Bye.
Monday.
Bye.